Here we go. It is day 2 of the Unit 3 practice test. We're going to go through numbers 7 through 12, and then we'll be done. Number 7, the function f of x equals the number of feet above sea level a rock climber is at x minutes. After 45 minutes, the climber reaches her maximum height of 800 feet above sea level. She stays on the mountain for 2 hours. What is the practical domain of f of x? Everything they say before this is really just telling you we have a function, right? With a few details about her rock climbing experience. Because, for example, for any function, you can put in an amount of time and figure out the other information. In this case, let's say it was 10 minutes in, you could see, okay, where was her height? 20 minutes in, where was her height? And so on. 45 minutes, we were told there was the max. So really, everything above the blue highlighted section is just telling you there's a function. The real question is, what's the practical domain? And we're told she stays on the mountain for 2 hours. While practical domain just means it's a real life situation. Domain is the x values. X values are time, and the time spent rock climbing started at 0 minutes and ended at 120 minutes. So the practical domain is 0 to 120 with brackets because those values are included. Number 8, compare the function g of x modeled by the graph. Okay, here's g of x and the function f of x right here. True or false? Explain. Let's see what they want to know. F of x has a greater y-intercept. Okay, so they want to know the y-intercepts. G of 1 is greater than f of negative 1, so they want to find out points on a graph or a function. F of x increases at a faster rate than g of x over the interval 0 to 3. So we need to look specifically at that portion of the graph to see what's happening. So what do you think is going to be our best bet to kind of figure all of these things out? Well, we could write the function of this, or we could create the graph of that. Because for me, I want to see them represented in the same way. Don't you? I feel it's easier to compare the two functions if they're written the same way. So I'm going to graph f of x. So let's do it. F of x, we see the absolute value signs. That tells us it's an absolute value function, so it's going to be a V shape. Okay? Now, for this, the vertex is always h comma v. So we take dishonest h and elevator v, and we plug them in. That's our vertex. Boom, point on the graph. We are on our way. What else is changing with f of x? Well, we have this 2 out front. Do you remember what 2 represents? Well, that's athletic A because it stretches or compresses. Since this is bigger than 1, it's going to be a vertical stretch. For the parent function, it looks like this, where there's a leading coefficient there, invisible of 1, meaning there's a slope of 1 over 1. Well, if we see 2, that means there's now a slope of 2 over 1, or just 2. So we're going to use that slope to then plot a second point. So we do that. We go rise 2, run 1, boom, 2 points. If we do that again, we even see not just the y-intercept, but it's also the point where the two graphs connect. They cross each other. Okay, so this line here, we're going to graph off to the side. We don't care too much about this side. We really care more about this side here and everything else going on. Okay, so we have the line graphed. That's great. Now we need to go through the questions. A, f of x has a greater y-intercept. Well, I just pointed out this key point, which happens to be the y-intercept for both graphs. So one is not greater than the other. That is false. B, g of 1 is greater than f of negative 1. G of 1, where is that? Well, it's wherever there is an x value of 1 on the g of x graph. Here's our g of x graph, and the point with an x value of 1 is right there. There's 1, right? X value of 1. What's y? It's 6. So g of 1 is 6. F of x function is here. F of negative 1, here's negative 1, is 5. Because when x is negative 1, y is 5. So is g of 1 greater than f of negative 1? Absolutely. 6 is greater than 5. True. And C, f of x increases at a faster rate than g of x over the interval 0, 3. I've highlighted that interval 0, 3 with these blue lines. So we really are analyzing what's happening specifically between those blue lines. And this statement says that f of x, this black line going up this way, increases at a faster rate than g of x. Well, yes, absolutely. This line is going up, way up here, and this line has a negative slope headed in the opposite direction. So that's false. Actually, f of x increases at a faster rate. That's true. Same logic, just had the wrong answer there. Okay, let's move on. Number 9, we have a table of values. It's representing bacteria in a culture every 20 minutes. And the big question is, how much greater is the average rate of change over the interval 40-60 compared to the interval 0-20? There's a formula for this. Do you know what it is? If you don't, I will set you up right now. Hopefully you can figure it out from here. This is the average rate of change formula if you're given values in a table. Now let's check the work. First, I dealt with the interval 40-60. Remember, A is the first value they give you, so 40. A is 40, B is the second value they give you, 60. F of A is the y value associated with A, so A is 40. The y value associated with it is 400, so F of A is 400. Same logic with B. B is 60, so F of B is 800. Now we have all 4 pieces of information we need, and we plug them in to our formula to get this. Be very careful. Make sure you put your f of b before f of a and your b before a and your numerator and denominator in the correct places, meaning you're not mistaking maybe b minus a on top and vice versa. Just putting everything in the right place, right? After that, it's just subtraction and division. We find the average rate of change between or over the interval 40-60 is 20. And we're going to do the same exact thing with the interval 0-20. Here's our information there. Identify A and B, f of A and B, plug them in, subtract, divide, and our main question again is how much greater is the average rate of change from the first interval to the next? And this had an average rate of change of 20. This is 5. Well, the difference between 20 and 5 is 15. So 15 greater. 10, 11, and 12 are all about combining functions. When you look at this question, you know what they're asking you? They're asking you to add f of x and g of x together. Quick reminder that this is just another way of writing this. Oh, that should be a g. These mean exactly the same thing. This is just a little shorthand way of writing it. So go ahead, try to add them together. Okay, so we write out our f of x function in parentheses to avoid mistakes, our plus sign because we're adding, and then our second function, our g of x in parentheses, again to avoid mistakes. Now, is this first function f of x going to multiply with anything? No. So we can remove the parentheses. But what are we actually multiplying here when we distribute? Is it positive 0? No, it's positive 1, right? So we distribute, and this time we get what we started with, but that's not always going to happen, especially when you subtract. So always use parentheses. Now that we've distributed, we have every term free from parentheses. There's nothing stuck anymore, so we can combine like terms. I color coordinated here. You can color coordinate as you go through these, or you can draw different types of lines. I'll show you what I mean in a moment. What you want to do here is go down the list and look, okay, at x cubed, underline with black. Let's look for any other x cubed terms. There's one, underline in black, that's it. So add them. 1 plus 2 is 3. X cubed is there to stay. Then we have an x term, underline in purple. Do we have any others? Yes, we do right there, underline in purple. Okay. Negative 2 plus 4, 2x. Underline in a different color, 3, that's a constant number. Any others? Yes, negative 4. 3 minus 4, negative 1. No other terms are left. Everything's been underlined, and all like terms have been combined. And this answer is in standard form, meaning exponents decrease. We start with 3, and then we go to 1, and then none. There is no x squared here, but that's okay. As long as your exponents are going down, you have it written in the right order. Now, a moment ago, I mentioned if you don't have colors, a different way to maybe stay organized and check these terms off is different lines. You could go straight line, squiggly line, squiggly line. You could draw a little lightning bolt. You could draw whatever symbol you want underneath to kind of match. You're matching up the like terms, right? Okay, let's combine some more functions. What are you being asked to do? Multiply, right? And I set up the box method. You could use that method or another. I find this to be the most popular and the most organized. Try it. Okay, notice my boxes here. This is because we have 2 terms times 3 terms. So I have 2 rows and 3 columns. Or you could set it up with 3 rows and 2 columns. It doesn't matter as long as your numbers of rows and columns match the number of terms you have. Now that we've done that, we want to multiply everything together. That's what the box does a good job of doing. And that is the bottom line. Everything needs to multiply with everything eventually. Okay? So if you want to do maybe a FOIL method like this, you could do that, where this needs to multiply with this, and this. And 3 needs to multiply with this, and this. And you would get all the same terms if you did it correctly. That's another way you could do it. And if you did that, you'd need to do it one step at a time like this. X cubed times 2x squared. That should be right there. 2x squared equals, show the answer, and so on. X cubed times x, and so on. Again, for me, that seems a little bit excessive, a lot of writing. The box method works better for me, but to each their own. If you like FOIL, do that instead. Okay, so the box method, remember, you set up your two functions. There's g of x, here's f of x. And then you're multiplying what's on the outside to get what's on the inside. So 2x squared times x cubed, 2x to the fifth. X cubed times x to the fourth. But you don't have to go in order. Most people normally do, but just so you're aware, you could multiply these first, x times 3, and then you could jump up here, -1 times x cubed. It does not matter as long as everything gets multiplied with everything. Okay? So the most common way this is done is to multiply this with this, and then this with that, and this with that. Okay? And your answers are in the boxes. And then 2x squared with 3, x with 3, -1 times 3. And then you get all of your products. That's what your boxes are full of. And you want to see if you have any like terms. And if you don't notice it yet, that's okay. You can pull this out and notice it later. But actually, we go 5, 4, 3, 2, 1, 0. There are no like terms. So we're going to have a pretty big polynomial, and there it is. Notice decreasing exponential order. 5, 4, 3, 2, 1, and none, and done. Finally, number 12, very similar to number 10. Subtract these functions, please. Parentheses are more important than ever on this one. And here's why. Again, the first polynomial will not multiply with anything, so remove those parentheses. But the second will, and we have a minus sign here, so every sign is going to change. What's negative will become positive. And we see that right here. Then just like before, underline as we go. I did not underline 4x to the fourth because there's no other x to the fourth terms. But there is more than one x squared term, underlined in black, more than one constant, underlined in blue. But there's also one x cubed term and one x term, so those stay alone. Okay, so we're going to combine and reorganize, because this needs to be in standard form, meaning decreasing exponential order once again. And if you don't do those things at the same time, that's perfectly fine. Let's say you want to combine your like terms and then organize after, do that. Whatever results in you making the least amount of mistakes. But I did both at once. That's number 12. And we are officially done with the Unit 3 practice test.